This lesson is Unit 3, Lesson 1, Properties of Equality. And our objective is students will be able to justify solving linear equations. So for this lesson, we are just going to go over the properties of operations and the properties of equality. And then once we get to class, we will actually practice applying these operations to solving linear equations. So we're taking something you know how to do, and now we're going to practice being good mathematicians and justify the reasons why we are able to solve the problems that way. First, let's go through the properties of equality. The first property of equality is the reflexive property of equality. And when you hear reflexive, think of reflective, like a mirror. So in symbols, this is represented by A equals A. And in words, we could say that a number is equal to itself. So for example, 5 is equal to 5. Something that seems kind of obvious, but there is a property that describes that. The next property is the symmetric property of equality. And in symbols, the symmetric property says that if A equals B, then B equals A. So if something is equal to another thing, you can write it that way, or you can flip it around. In words, it means if numbers are equal, they will still be equal if the order is changed. Next, we have the transitive property of equality. If A equals B and B equals C, then that must mean that A equals C. Notice that we have A and we have C, and both of them are set equal to B. If numbers are equal to the same number, then they are also equal to each other. A and C are equal to each other because they're both equal to B as well. Kind of like we take out the middleman on that one. Next, we have the addition property of equality. If A equals B, then A plus C is also equal to B plus C. In words, that means that adding the same number to both sides of the equation doesn't change the equality of the equation. So it changes the value, but it doesn't change the fact that the left side is equal to the right side. Our fifth property is the subtraction property of equality. In words, if A equals B, then that means A minus C equals B minus C. Kind of like the addition property. So subtracting the same number to both sides of the equation doesn't change the equality. The left side still equals the right side. Our sixth property of equality is the multiplication property of equality. If A equals B and C does not equal 0, then that means A times C equals B times C. In words, it means that multiplying both sides of the equation by the same number other than 0 doesn't change the equality. So if the left side equals the right side, and you multiply both sides by the same number, it doesn't change the fact that the left side equals the right. All of these properties are similar: the addition property, subtraction property, multiplication property, and then we finally have the division property of equality. If A equals B and C does not equal 0, then that means that A divided by C is equal to B divided by C. In words, dividing both sides of the equation by the same number other than 0 doesn't change the equality. And finally, our eighth property of equality is the substitution property. If A equals B, then B may be substituted for A in any expression containing the letter A. So if A is equal to B, then that means you can replace A with B anytime you see A. If two numbers are equal, then substituting one in for another doesn't change the equality. So those are the 8 properties of equality: reflexive property, symmetric property, transitive property, addition property, subtraction property, multiplication property, division property, and substitution property. We now have five properties of operations. These 5 properties, you should have talked about them before. You might not remember their names because we don't talk about them very often, but they are properties that you are familiar with, and they have allowed you to get to this point in math. The first one is the commutative property of addition. That means if you have a plus b, that's also equal to b plus a. A specific example of that is 3 plus 8 is equal to 8 plus 3. Both of those equal 11. Next, we have the associative property of addition, which means that a plus b in parentheses plus c is also equal to a plus, in parentheses, b plus c. An example of that is 3 plus 8 plus 2 is equal to 3 plus 8 plus 2. You would do the parentheses first, which on the left side gives us 3 plus 8 is 11, 11 plus 2 is 13. On the right side, we do the parentheses first, 8 plus 2 is 10, plus 3 is 13. So both situations end up adding to 13. Our third property is the commutative property of multiplication. We've already talked about the commutative property of addition. That's where we can add things in either order and it equals the same thing. Same is true for commutative property of multiplication. You can multiply a times b or b times a. It's still going to equal the same thing. For example, 3 times 8 equals 24. 8 times 3 also equals 24. Notice that there is not a commutative property of subtraction or one of division. 2 minus 5 is negative 3, but 5 minus 2 is positive 3. It's not the same number if you switch the order. We also have the associative property of multiplication. That's saying the quantity of a times b multiplied by c is equal to a multiplied by the quantity of b times c. It doesn't matter which numbers you group. If it's multiplication, you can multiply in any order and it will equal the same. 3 times 8 is 24, times 2 is 48, 2 times 8 is 16, times 3 is 48. Our last property is the distributive property of multiplication over addition, what you like to call distributing or distribution. So if I have a times the quantity of b plus c, that a gets multiplied to both b and c, so it becomes ab plus ac. We have an example here that says 3 times the quantity of 8 plus 2 would become 3 times 8 plus 3 times 2, or 24 plus 6. So those are the 5 properties of operations: commutative property of addition, associative property of addition, commutative property of multiplication, associative property of multiplication, and then distribution. Like I said earlier, we're going to use these properties to justify and explain the reason behind why we solve equations the way we do. We'll also use some of these properties later on in the unit when we move to solving systems of linear equations not by graphing.